Hello everyone. We'll be solving a couple of questions on programming language translators. The first question is based on phases of a compiler. We'll be solving it with an example. The second question is data flow analysis. We'll be describing what data flow analysis is, and then with the help of an example, we'll be providing further discussion. The third question is operator precedence parsing.
The first question is as follows. With the help of a neat block diagram, explain various phases of a compiler. Also, write down the output of each phase for the expression a equals b plus c into 50. This is the block diagram for a compiler, and it shows us the various phases of a compiler: the lexical analyzer, the syntax analyzer, semantic analyzer, intermediate code generator, code optimizer, and the code generator, along with the symbol table manager and the error handler, which helps in converting the source program into the desired target program. The first phase of a compiler is a lexical analyzer. It is otherwise called as linear analysis. The lexical analyzer, in which a stream of characters making up source program is read from left to right and grouped into tokens. The blanks separating the characters of these tokens would normally be eliminated during lexical analysis. The second phase is the syntax analysis. It is also known as parsing or hierarchical analysis. It involves grouping the tokens of source program into grammatical phrases, thereafter used by the computer to synthesize the output. In syntax analysis, source program is represented by the parse-tree. Semantic analysis. It checks the source program for semantic errors and gathers type information for the subsequent code generation phrase to do type conversion and ensure the correctness of the source program. It deduces syntax analyzer output to identify the operator and the operands of the expression and the statements. The next phase is the intermediate code generator. The intermediate code representation should have two important points. The first one is it should be easy to produce and it should be easy to translate into the target program. There are three common ways to represent the intermediate code: the tree address code, the syntax tree, and the postfix notation. Code optimizer. This phase attempts to improve the intermediate code so that faster running machine code can be produced. Some optimizations are trivial. There is greater variation in the amount of code optimization different compilers perform. The last phase of the compiler is the code generation. Generation of a target code consisting normally of a locatable machine code or assembly code. Assignment of variables to the register is a crucial point and is done in the phase. Memory locations are selected for each of the variables used by the program. The output for lexical analysis is as follows. The given expression was in the form a equals b plus c into 50. A, B, and C are letters, so we have to convert them into various identifiers ID1, ID2, and ID3, and we leave the number untouched. In syntax analysis, we construct a parse tree out of the lexical core analyzer, the output that we obtain from lexical core analyzer, in such a way that the precedence of the operators are taken into account. In semantic analysis, what we do is that we convert the data type to match with the data type that the machine supports or uses. In this case, we converted integer to float data type as it is a data type that is supported by the machine. In intermediate code generator, we have a set of instructions, and to convert the initial expression into a set of instructions, what we have to do is we have to follow three main methods, and we generally use the three address code method, and using which we obtain the following output. In code optimizer, what we try to achieve is lesser number of instructions so that the machine could execute the instructions faster, and accordingly the previous instructions were modified. in coordinator, what we do is that we represent the initial expression in the form of assembly code, and we have to note that the allocation of the variables to the registers are taken care of here.
Now coming to the second question, which is write a short note on data flow analysis. Data flow analysis is a technique for gathering information about the possible set of values calculated at various points in a computer program. An execution path from point 1, that is P1, to point Pn is a sequence of points P1 to Pn such that for each I from 1 to n minus 1, either P1 is a point immediately preceding a statement and Pi plus 1 is the point immediately following the same statement, or Pi is the end of some block and Pi plus 1 is the beginning of the successive block. In general, there is an infinite number of paths through a program and there is no bound on the length of the path. A data flow value for a program point represents an abstraction of the set of all possible program states that can be observed to that point. The set of all possible data flow values within the domain to the application under consideration can also be termed as an analysis of the data flow in a given program. Data flow analysis also examines how variables change across control flow edges. The program's control flow graph is used to determine those parts of a program to which a particular value assigned to a variable might propagate. The information gathered is often used by compilers when optimizing a program. The canonical example of a data flow analysis is reaching definitions. So basically, in a data flow analysis question, you'll find that the life cycle of a variable during program execution can be categorized into three. That is, the variable is being defined with a value or declared. That is, the second one is the variable is being used somewhere in the program, and finally the variable is killed. That is it's deallocated from the memory. Now consider the example shown. In the code section, we have defined four variables and a while loop. To the right, we have the control flow graph. Now, to form the analysis of the variables, for the first variable total, we can find that the variable has been defined on line number 1, it's been used and defined again on line number 5, and it's been used to calculate the average on line number 9. At the end of the code, the variable is killed. On the last column, we can find the graph that denotes the line numbers and the action that has happened during the program execution. Now consider the given example. In the code section, we have defined four variables and a while loop. The four variables are total, count, and number. The average is found out using the variables total and count. To the right, we have the control flow diagram for the given code section. Coming to the data analysis part, first for the variable total, we can see that the variable total has been defined in line number 1. It's been used and defined again on line number 5 while calculating the expression total equals total plus number. It's been used again in line number 9 for calculating the average. As the program execution is done, it's been killed on line number 11. Now, for the variable count, you can see that it's been defined on line number 2. It's been used again and defined on line number 6. For calculating the average, it's been used again on line number 9. And finally, after the program execution is done, it's been killed on line number 11. For the variable average, the first time the variable has been defined is on line number 9. Then it's printed out, which means that it's been used, and then finally after the program execution it's been killed on line number 11. Coming to the last variable, that is number, you can see that the variable number is first defined on line number 3 with the function get number, which gets any number from the input. It's again used in line numbers 4 and 5 for checking out the condition in the while loop, and then again for calculating the total. It's been defined again on line number 7 to calculate to get the number again from the input stream. And finally, after the program execution is done on line number 11, it's been killed.
The third question is as follows. Construct operator precedence relation and function for the given grammar. From the question it is evident that one of the production consists of two adjacent non-terminals or variables. This violates the rule for the grammar uh, to be an operator grammar. So therefore this is not operator grammar. Hence we have to convert it into an operator grammar. For that we use the various productions and we derive the grammar which does not violate the operator grammar rule. That is, there should not be adjacent non-terminals or variables. This is an operator grammar. Now we try to form a string from the various corrections. Finally we obtain p, which gives id into id, which is the string that we are gonna use for the construction of the operator precedence table. The given string is p, which gives id into id, and the operator precedence table for the various operators encountered is as follows. And now the operations start. Initially in the stack, the dollar symbol is present, and the buffer consists of the string followed by a dollar symbol in the end. The first action is to compare the dollar symbol with id, and the presence of id is greater than dollar symbol, so id is added to the stack, and the buffer consists of the remaining symbols. So on the next step, id is compared with the multiplication symbol, and the precedence of id is more than the multiplication symbol. Therefore, it is the identifier id is deleted from the stack. Now, the next step compares the dollar symbol with the multiplication symbol, and the multiplication symbol has more precedence than dollar symbol. Therefore, again, the symbol is copied to the stack, and in the buffer, just id and the dollar symbol remains. This goes on, and in the end, in the stack only the dollar symbol remains, and in the buffer only the dollar symbol remains. In such a case, the string is accepted. So as shown here, uh, that is followed. Only the dollar symbols remain in both stack and buffer. Therefore, the string is accepted. Thank you.